Hello everyone, and welcome back to the Fluctus Channel. The Sikorsky UH60 Blackhawk is one of the most versatile and widely used utility helicopters in the world.
The Blackhawk is an incredible machine. The maneuverability, the power that machine possesses, and just the functions that it can perform. Aeromedical evacuation missions, air assault movements, humanitarian missions, troop transport. It is multifaceted and is used for numerous things.
Introduced into U.S. Army service in 1979, it was developed to replace the UH-1 Iroquois as part of the Utility Tactical Transport Aircraft System program. Designed for speed, durability, and adaptability, the Blackhawk features twin General Electric T700 turboshaft engines, a four-bladed main rotor, and rugged landing gear capable of operating from unprepared terrain. Its primary role is air assault, moving troops quickly into and out of combat zones. It can carry 11 fully equipped soldiers or up to 9,000 pounds of cargo internally or slung beneath the fuselage. The UH-60 is also used for medical evacuation, command and control, search and rescue, and special operations. Armored crew seats and redundant systems enhance survivability, while door-mounted M240 or GAU-19 machine guns provide defensive firepower. The Blackhawk has served in nearly every major U.S. military operation since Grenada in 1983. To provide pilots with flight training, including emergency procedures, without potentially damaged aircraft or putting personnel at risk, the U.S. Army uses full-motion simulators for training. UH-60 Blackhawk full-motion simulators are advanced training systems that replicate the helicopter's cockpit, flight dynamics, and mission environment with remarkable realism. Housed in a motion platform, these simulators use hydraulic or electric actuators to create the sensations of takeoff, landing, turbulence, and maneuvering. Inside, pilots train in a fully replicated UH-60 cockpit with functional controls, digital displays, and realistic audio cues. High-resolution dome or wraparound visual systems project 3D terrain, weather, and night vision imagery, allowing crews to practice under diverse conditions without risk or fuel costs. Instructors can introduce emergencies, system failures, or combat scenarios at will, enabling pilots to rehearse responses that would be too dangerous in real flight.
Got a missile beaming.
Blackhawks can be equipped with external fuel tanks to extend their range for long-distance missions, or in areas with limited refueling options. These tanks, typically mounted on external stores, support systems or pylons, come in various capacities, with the most common being 230-gallon and 450-gallon models. Refueling can be performed through standard ground fueling or forward area refueling points, or FARP, in the field. Ground crews connect fuel hoses to the tank's refueling ports, ensuring proper grounding to prevent static discharge. During hot refueling with engines running, strict safety protocols are followed, with fire suppression equipment and trained personnel on standby. In operational settings, FARPs allow UH-60s to land briefly, refuel from fuel bladders or tanker trucks, and quickly return to the mission. The process minimizes downtime and keeps helicopters operational in remote or contested environments.
Fuel 1 gallon.
Aerial refueling is so common that one would think this is an easy process. Refueling aircraft in flight takes a lot of skill and finesse from both the pilot and the refueling boom operator. Aerial refueling is performed on jet fighter aircraft. Helicopters, tilt-rotor aircraft, bombers, big cargo aircraft, drones, reconnaissance aircraft, special operations aircraft, Air Force One, and even some civilian and experimental aircraft. In aircraft like the KC-135 Stratotanker, pilots and flying boom operators, also known as boomers, must follow exhaustive checklists before they can take off. Because the aircraft has many different systems, these checklists ensure that the aircrew does not accidentally miss any detail, which could lead to major issues after takeoff or during refueling. And that is only the pre-flight checklist of several pages. While in flight, they have a couple more separate checklists to go through. How exactly does aerial refueling work? Aerial refueling starts with a process where the two aircraft head almost straight towards each other, offset by 8 to 10 miles and 1,000 feet of vertical separation. With about 18 to 20 miles of separation, the tanker makes a 180-degree turn and heads in the opposite direction. From this point, the receiver climbs to chase the tanker. From the pre-contact position behind and below the tanker, the receiver waits for the authority from the boomer to move to the contact position. Once contact is approved, the receiver approaches the tanker at a rate of about 1 foot per second. From this point, fuel is transferred at 900 gallons per minute, depending on the refueling method. Once the process is completed, contact is broken between the aircraft. There are two types of aerial refueling systems in use around the world. Most countries in the United States Navy use the probe and drogue refueling method. With this method, the tanker trails a hose with a drogue attached. The receiver aircraft is equipped with a probe, which the pilot inserts into the drogue for refueling to start. Another method, mainly used by the United States Air Force, is the flying boom method. With this method, the boomer flies a boom with V-shaped control surfaces into the refueling nozzle of the receiver.
6. Yeah.
Once the connection is secure, the fuel transfer will start. With the probe and drogue method, the receiver pilot does most of the flying work, but the probe takes up more space on the aircraft. When using the flying boom, the boomer does all the work, with the pilot simply following radio instructions or light signals on the bottom of the tanker.
And boom interphone check.
Getting boomers trained can be expensive, but simulators like the BOWST, or Boom Operator Weapon System Trainer, save a lot of time and money. Trainees spend at least 11 flight hours on the BOWST as part of their training regimen. This not only saves money, but prevents a boom from snapping off or going through the windshield of the receiver. It makes even more sense when you realize that the receiver is flying in the bow wave turbulence of the KC-135. Another aircraft is more capable than the KC-135, which dates from the 1950s. The KC-46 Pegasus represents the next generation of aerial refueling tanker. Where the boomer was lying prone in a pod at the rear of the aircraft. The KC-46's boomer was sitting at a console called the Aerial Refueling Operator Station, or AROS.
This is the boom. And so you have, we call it the H-tail, if you will. You have your rudders and your elevators for the boom. And then the entire length of it, this is what drops down and comes into the air refueling envelope. There's a green tube that comes out of the middle of it. That's the telescope tube. That's what extends and retracts, and that's what houses the nozzle that mates up with the receiver airplane to give them the gas required to accomplish the mission.
The AROS is situated at the front of the aircraft and uses cameras to provide the boomer with visual cues. For that reason, the simulator for the AROS is designed to look exactly like the AROS. The system is more sophisticated than the KC-135, and the boomers have an easier time due to their seated position and the support provided by the new technology. Since the KC-135 still plays a major role in the United States Air Force, pilots must still be trained and know how to react to emergencies. Simulators are used to teach them how to fly the aircraft, but importantly, they can also practice emergency procedures in the simulator. Not only does the simulator enable pilots to learn how to handle emergencies, but it also saves a lot of money. It is estimated that the simulator saves $5,820 per hour of usage. Pilots who are trained in this flight simulator, like the one at MacDill Air Force Base, find it much easier to fly the real KC-135, and they can handle emergencies much easier. One issue that can occur with the KC-135 is fuel fire. To combat the fire, emergency response teams need to train in a realistic scenario, and using a dummy aircraft with generated flames gives them exactly that opportunity. Aircraft fires spread quickly, so emergency response personnel are taught to get to the aircraft as quickly as possible and rapidly attack fires with their water cannons. These cannons are used to spray the fire with water or fire retardant, and a bed of foam is laid down to help smother the fuel fire. From the battlefield to humanitarian relief, the UH60 Blackhawk continues to prove itself as one of the most adaptable helicopters in service, capable of operating in nearly any environment. Its effectiveness is enhanced not only by advanced equipment like external fuel tanks for extended missions, but also by the rigorous training of its crews through high-fidelity simulators that replicate both flight and refueling conditions. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.